Good morning. Today we're going to cover DeMoivre's theorem, which is a way to multiply complex numbers that are raised to exponents higher than 2. So for example, if I had asked you to multiply -2 minus 2 rad 3i, let's say to the third power, back in algebra 2, you would write that out 3 times, and then you would FOIL, and then you'd have to multiply again, and it'd be long and cumbersome. But now, because we have a way of expressing complex numbers in trigonometric form, which looks like this, we've been covering this for 3 days now, what we're going to do is we're going to say, fine, let's raise this to some power. Now, if I raise this side to a power, that means that this side will also be raised to that exact same power. That's the only way to keep this equation the same. And the formula, what DeMoivre came up with for this, is that this is going to be equivalent to r to the n, and then cosine n times that angle plus I sine n times that angle. Okay, so that's the theorem. That's the formula that you're going to be plugging into. So in fact, let's go ahead and do the problem that I just stated up top right here. So step number 1 is you're going to write it in trig form. Okay, so you will be given the problem in standard form, right? Normal complex form, a plus bi, like you're used to. But I want you to write that problem in trig form. So let me draw a very quick little picture. I know that that dot, that location, is in the third quadrant. This is -2. This is -2 rad 3. And if I figure out that radius, I'm pretty darn sure that's a 4. All right, and again, you can figure that out for yourself. We've done it before, but the radius there is 4. So in trig form, this particular point is 4 times the cosine of, now I need an angle, right? This angle right here. So I'm looking at this saying to myself, fine, the cosine of, let me move that up, you can't see it. The cosine of that angle is the adjacent side over the hypotenuse, which is -1/2. And in the third quadrant, the thing that has a denominator of 3 is 4 pi over 3. So now I can write this in trig form. Okay, so that's the trig form of this complex number. Now, I'm raising this to the third power, right? That's what I'm trying to do. I'm trying to multiply it times itself 3 times. So here's what the formula says. Take the radius and raise it to that power, so 4 to the third. And then inside here, you're going to multiply each of those angles, right? It's the same angle, but we're going to multiply it by 3. So it'll look like this. The cosine of 3 times 4 pi over 3 plus I sine of 3 times 4 pi over 3. All right, that's what the formula looks like. So this on the outside, 4 to the third is 64. Simplifying this just a little bit, this is the cosine of 4 pi plus I sine of 4 pi. And if I simplify each of those, right, I know exactly where 4 pi is on the unit circle. It is right here at 1, 0. So the cosine at that location is 1 plus I times the sine at that location is 0. And if I just multiply this stuff together, I get 64. Right? And if you don't believe it, if you don't believe me, take this, that was the original problem, write it out 3 times, see if you get 64. I promise that you will. So that's DeMoivre's theorem. Again, it's a fast lesson. I will be back tomorrow to answer any of your questions. Good luck, and I'll see you tomorrow.